Hello everyone. So today we are discuss with that ARM architecture. So ARM expansion is advanced risk machine. So its architecture is based on risk, that is called as and reduced instruction set computing. So it principles prioritizing the efficiency and low power consumption. A standard ARM architecture block diagram is consist of several core functional units connected via an internal buses. The key functional blocks are arithmetic logic unit, that is ALU. So it is used for a central unit that performs all the arithmetic, that is called an addition, subtraction and logical operation and or not, and the data retrieved from the registers. Register bank, a set of 32-bit register used for high-speed data storage and manipulations. It is includes the general purpose register, that is an R0 to R12 used for common data operations. Then stack pointer, that is an R13. So it points to the top of the stack memory. Then link register, it stores the return address of these subroutines. Then program counter, it holds the address of the next instruction is to be executed. Then parallel shifter, so an unique ARM component that can shift or rotate an operand before it reaches the ALU. So this allows complex operations like shift and an add to be performed in a single instruction cycle execution. Then booth multiplier, so it is a specialized unit for optimized high speed multiplications process. So the high speed multiplication process we can use with that booth multiplier for high speed data transfer also. The instruction decoder, so it interprets fetched instruction and generates the control signal necessary for rest of the processor to execute them. Then the control unit, it manages the flow of data within the processor and coordinate the timing for all the functional blocks. Then CPSR, so it stands for current program status register. It contains conditional code flags, that is a negative flag, zero flag, carry flag and overflow flag, and control bits for processor modes and interrupt masking. Then data flow and architecture features are a load store architecture. So the ARM processor do not operate directly on memory. So the data must be loaded in from the memory into a register and processed and then stored back to a memory. So the process is called as a load store architecture. So these unique features in the ARM processor it will have. Then the pipelining execution. Most of the ARM cores are used a multi-stage pipelining. So pipelining is the process is to execute, fetch, decode and execute process. So it's to be an overlap instruction execution, increasing the overall throughput. Then next data flow architecture features are bus interface. It connects the internal processor core to external memory and peripherals. Modern design often use the AMBA, that is called as an advanced microcontroller bus architecture protocol for these connections. So these are the data flow and architecture features of ARM processor. We have the block diagram for the particular ARM processor general. So this block diagram is a general block diagram. Then we go for with that ARM organization. So this will be a specified organization for ARM 7 or ARM 9. So first one is a register file. So it has a 2 read ports and 1 write port. Along with that 1 read 1 write port for reserved for register 15, that is an R15. Then barrel shifter, so it shifts or rotate one operand from any of the 1 bits. Then ALU, so it performs the arithmetic and logic function it's required. Then the memory address register, and also it will be used for increment purpose, memory data registers, then in instruction decoder and associated control logic. So these ARM implementations refer how the ARM processor architecture and it known with an efficiency is realized in the hardware like CPU, in phone, server or software. The software in the sense we can use for the simulator FPGA through an specific designs and pipelining execution, that is called an fetch, decode, execute. Then integrated components or ALU, barrel shifter, and features or thumb mode, then optimize instruction set to balance the performance, power and area of the applications from IoT to supercomputer. The key aspects of ARM implementations are core components. So core components use a register file architecture or ALU, that is an arithmetic logic unit, barrel shifter for fast shift and rotation, and controller like interrupt controller connected via buses. Then second key aspects of ARM implementation is instruction pipelining. So it's implemented with the stage, that is a stage of execution for fetch, decode and execute, and optimization like forwarding and branching the prediction to speed up instruction flow often with two-phase clock cycle. Then barrel shifter optimization, so it allows shift or rotate operation within the same clock cycle as the data processing, boosting performance without extra hardware. Then instruction set variation, it supports different profiles, that is an ARM, different version of the processor, that is a Cortex A for applications, Cortex M for MCUs, and features like thumb mode. So it is a compact 16-bit instruction for varying needs. Then hardware realization, so hardware realization in the case we have to use with that ASICs or system on chip to customize the chip, integrating ARM cores with peripherals as a memory and I/O for specific products, for example smartphones or car, etc. Then FPGA, so it is a softcore processor like ARM Cortex-4 or mapped into a field programmable gate array for optimized size or power in Internet of Things or IoT. So power and area efficiency, so it is the techniques like earlier terminations in multiplier and logic optimization. It reduces the resource usage, crucial for battery powered devices. Then the software implementation, so it can be simulated environment like GEM5, allowing detailed study of the architecture and features. So these are the some examples we have to decide use for ARM Cortex processor. Mobile devices, Cortex A series processor offer higher performance and low power for phone and tablet. IoT, so ARM Cortex M core are optimized for small and efficient embedded system and sensor. Then servers and PCs, high performance Cortex X or Neo cores, power demanding applications. So these are the some concepts we are implementing in the ARM processor as an applications. Okay.